Okay, today we'll be covering a learning target from 2.7. I can solve polynomial inequalities. We will be skipping the rational inequalities this year to help us get on track and move forward this year, okay? So you can cross that out. All right, we're going to skip these review questions. We've been working a lot on solving equations, finding zeros. Let's just jump right into these inequalities, okay? All right, the idea of this table right here is just to review some things you went over a long time ago with inequalities. All right, so when we see the less than or equal to, let's just use this example. It's real basic, x is less than or equal to 3. Obviously, you can see down here on the next page, they get a little more complicated. There'll be quadratics and cubics. But if we have this linear one, how do we graph this? Well, one way to test this is what you want to do is go to your boundary point first. So at 3 on the number line, I'm going to start by just putting a circle over here. Okay, and let's test the boundary point. Is it a solution? So if I take 3 and plug it in for x, and I check its truth value, is this true? Is 3 less than or equal to 3? Yes, it is true. So to show that it's a solution, we want to fill in the dot. Okay, fill in that circle at 3. Now we got to figure out which way to go. Okay, if you're good with inequalities, you may already know where to go. Okay, but what you can do is grab a point to the left and grab any number to the right, and you just test them. So I'm going to grab a number to the left. Let's grab 1. Plug it in. Is 1 less than or equal to 3? Yes, that's true. What about a number to the right, like 5? Is 5 less than or equal to 3? That's false. Okay, any number I would have grabbed to the left would have created a true statement. So that's why we do a collection of dots, right? If we took a lot of these dots and connected them, what would we have? A line. So we just connect those dots with a line and show the solutions that way. Okay. All right, so when we have less than, sometimes you might have a linear equality. Let's just up the stakes a little bit and do something like this. X plus 4 is less than 4. Well, we need to solve this for x. So we subtract 4 from both sides, and we'd get x is less than 0. Okay. All right, so I go over to the number line. I start with an open circle of 0 and decide if I should close it or not. Now you shouldn't, because when we test this and I plug in 0 here, 0 less than 0. No, that is not true. That's false. So we keep it open. Okay, close it if the boundary is true, like the last one. Keep it open if it's not true. And where is x less than 0? I mean, you should be able to just figure it out, but if you need to take more points, one to the left, one to the right, and do that, you should. So x is less than 0 going this way. Okay. All right. Let me give you this one. 3x is greater than or equal to negative 6. Just like equations, you solve inequalities just like equations, with the exception of multiplying or dividing by a negative. Here we just need to divide by a positive, so I do not turn the inequality around, but if it was a negative 3, I would. Okay, so our solution is x is greater than or equal to negative 2. All right, so our rules, we can start making some rules here. When we have a line underneath it, the boundary point will always be filled in. It's always going to be true. So this is when we close it. And if there's not a line underneath, we're going to keep the circle open. So we can start following that rule now. There's a line underneath it, so we're going to make this closed because negative 2 is a solution. Okay, so close it. What numbers are greater than or equal to negative 2? Numbers like negative 1, 0, and so on. So we're going this way. Okay. By the way, the authors like to use parentheses and brackets on these. So instead of a closed circle, they'll put bracket on the number line going this way, like that. For open circle, they'll do parentheses like that, right on the number line. Okay, so bracket for closed, parentheses for open. All right, and just one more. So now we've got less than and then two greater thans. X minus 1 is greater than negative 1. So if I add 1 to both sides, we get x is greater than 0. Okay, this should be open again. There's no line underneath. So greater than 0 is this way, or parentheses this way. Okay, here they're asking us to just practice checking to see whether the value of x is a solution of the inequality. We're actually going to skip 5 because this is rational, the one that I had you skip up here. We're going to skip 5 for now. Let me get you going on 4a and have you try b and c. Okay, so to determine if this is a solution, we're going to plug 0 in here. And I'm going to do this. 0 squared minus 4 times 0 minus 5 is greater than 0. Do the math. I get 0. Take away 0. 0 minus 5 is negative 5. Is that greater than 0? Well, negative 5 is over here. That's below 0 on the number line. So that's not true. So if it's false, what that means is it's not a solution. So the final answer to A is it's not. X equals 0 is not a solution. Okay? All right, you try B and C. Go ahead and pause the video and try. All right, so negative 4, when we plug that in, do the math, you should get 27 on this side. Remember, if you're squaring a negative, put that in parentheses. If you put the negative outside or didn't include parentheses, you'll get the wrong answer. So 27 is greater than 0. That is true. What does that mean? X equals negative 4 is the solution to this problem. Okay. 5, I got 0 is greater than 0. Nope, that's not true. It's almost true. If I had a line underneath it, I'd say it's a solution, but I don't. So it's not a solution. Any questions on number 4? Okay, turn the page. Okay, so on the first page, and we're going through these standard rules, all of these were linear equations, degree 1, degree 1, degree 1. Okay, now we're going on to degree 2 and degree 3. Okay, so here's how we treat these a little bit differently. They still start by solving the equation to find the zeros, just like we solved these. We're going to do the same thing here. So step 1, find the zeros of the polynomial, and then arrange the zeros in increase in order from least to greatest. These zeros are the key numbers. I'm going to call these boundary points as well. So these key numbers are also called boundary points. We like to call them boundary points because they're going to create boundaries on the number line and help us establish the intervals. And that's what's going to happen in step 2. We'll use these boundary points to establish test intervals. I'll show you how to set up a table to organize our thoughts on that. All right, and in the table, we're going to grab some x values to test, and it'll lead us to the conclusions, basically. All right, so here we go. Step 1, find the zeros of this polynomial. You can kind of ignore the inequality sign altogether when doing step 1. So step 1, 2x squared minus 8x, just put equals 0 for now, okay? And now it just becomes an algebra 2 problem and some things we've been reviewing this year. How can I solve this quadratic? If you can't factor it, I suppose you could jump to the quad formula right now, but this is easier to factor. Okay, there's a 2 in common and an x in common. So 2x times x is 2x squared. 2x times negative 4 gives me the minus 8x. Okay, now I use the zero product law. I'm going to set 2x equal to 0, and I'm going to set x minus 4 equal to 0, and solve those. So I get x equals 0 and positive 4. These are called, they call them key numbers, right? I'm calling these boundary points. So I think the best thing to do right now is to go to your number line and just start by plotting those. This isn't labeled, but let's just do it this way. 0, it's just going to go every 2, 4, 6, 8, negative 2. That should work. Just create your number line depending on the numbers you get and the zeros you get. All right, and I'm going to start by just creating some open circles at 0 and 4. Okay, I kept them open because you got to remember the rules. Basically, we're checking this. Are the BP's, boundary points, are the BP's solutions? Okay, the long way to do this is to take 0 and 4, plug them in, and if I plug those in, just like I did on the last few problems on the last page, I'd get this. 0 is greater than 0. They're not solutions. Okay? Like I said, that's the long way. I want you to start using the rules and shortcuts. There's no line underneath it. Keep it open. Okay? All right, so these kind of create boundaries. So this is the part that takes a little bit of time, but I want you to do this to set yourself up for success. I want you to title this Intervals, X Values, and then down here I'm going to title this Solution. I'll put a question mark because we're going to check to see if it's a solution. All right, so the boundary points naturally create some intervals. I'm going to put in a little dashed line at 0 and a dashed line at 4. You can do that too if you want to help see it and give you a visual aid. My first interval of values is going to be from negative infinity up to this boundary point of 0. And then this is going to be my next boundary, and then this is going to be my next boundary. Okay, so here's the first interval of values we need to check. Negative infinity up to 0, and I'm using parentheses because it was open circle. We're not including it. If it was closed, I'd use a bracket right there. What's the next interval of values? We'll look at my boundaries from 0 to 4. So 0, 4, and then my last interval was 4 to positive infinity for x. Okay. All right, next thing you do is just get on to step 3. Now it says choose representative x values to test each interval. You have some freedom here. You're supposed to choose any x value from negative infinity to 0. Okay, I recommend just keep them small. Keep numbers easy. I'm going to just go with -1. But if you wanted to choose -2, go ahead. We'll get the same result. Choose a number between 0 and 4. I'm going to go with 2. Choose a number from 4 to infinity. I'm going to go with 5. Okay. All right. So to test to see if x is a solution to this or not, we're doing what we did on number 4, where you're plugging these in and checking these. But there is a shortcut to this. I can show you how to do this with a table. Let me show you by hand, and then I'll show you the table. So if I'm going to check -1, it's going here, right? So 2, -1 squared minus 8 times -1, is that greater than 0? Okay. Let's see, 1 times 2 plus 8, so we end up with 10. So I get 10 is greater than 0. So since 10 is greater than 0, -1 was a solution. So would anything I picked over here. -2, -3, I would have got a different number, but I would have got a true statement right here. So the answer is yes. So it basically means anything to the left is going to work. All right, so on our number line, we show it this way. Okay. All right, let me show you the shortcut though, because plugging it in, evaluating it, you're going to appreciate this shortcut. So grab your graphing calculator. Okay, so whatever your function is, go ahead and plug it in. So 2x squared minus 8x. And I'm just going to use the table feature. That's all, to quickly evaluate all these. So instead of plugging in 2 and 5 and redoing that, if I go to table now, second graph, you should see these x values. Now if I scroll up to 2, I can see what the output value would be, -8. So now I know what this number is right here, right? So -8 is greater than 0. What about 5? It says right here it's 10. So when I plug in 5, I get 10 is greater than 0. Okay.